All right, some technical information. So often you're going to have to share with me a link to some website, a link to a Google Doc, for example. And one thing you want to avoid doing is just pasting in the raw address like that. Two problems with this. One, it's ugly. And two, when somebody gets this, it's not clickable. It doesn't work. So the correct way to put in a link to a website is to just put some descriptive text, like what is this for, right? So this is, maybe I'll call it link to data. And then highlight that whole phrase or part of the phrase, like maybe I could highlight just the word data, and then that's where we put the link. So we always want to hide these ugly links, they're called URLs, behind link text. And then that text right there becomes clickable. And the way I'm putting stuff in here is the same way when I have a text box for you to fill out for an assignment. It works the same way. All right, so let's demonstrate that again. So the question was asked, like, where are the data sets that the book references? So I downloaded a bunch of them into my Google Drive, so you can get them here from the Useful Websites page. And then they have a website that is referenced in the beginning of the text, like right when you open the book, it says, hey, go to this website right here. And then there they have a link to the data sets. And then you can pick which version of the text you have. So I'm going to go with this one here. And then they're all here in different formats. And when I'm working in Google, I either use the CSV version or the XLSX one, which is an Excel file. And Google can actually read probably can't read the Minitab or the Fathom. And then for those of you who end up taking the stats lab, I'm going to do some work with R there, because that's kind of the new trend at universities with statistics. Instead of using a spreadsheet or a calculator, they often use the R programming environment for statistics. All right, so let's put a link to that. So this would be textbook data sets. And so again, I make my text, I choose what part of that text is going to be my link, and then I just click the link button above and then paste in the address that I copied. Another thing about web addresses, never manually type the web address, always get to the page, and then from that page, copy the address from the address bar at the top. So there'll be several assignments where you're going to have to get me some kind of link like that for your work. Okay, so there's a couple of links to those. So let me just demo one of those. Let's take a look at all countries. I'm going to grab the CSV file. If you're on a laptop with like storage issues, like you're running out of room, CSV is always less space than XLSX. And just putting downloads for now. And then to use this, then I just put it in my Google Drive. So it's in my downloads here. So from here, I could go to my Google Drive, and then I could just drag and drop it anywhere I want in my Google Drive. So now I have another version of it called All Countries. If I double click in my Google Drive, it'll give me a preview. If I move my zoom bar out of the way, I can choose Open with Google Sheets, and then it's an editable spreadsheet. Okay, so this is a good place to start. So what I wanted to first do today is do a little bit of review of stuff we've covered. So here I have a big data set. A question about this data set is, what are the cases in this data set?
The countries.
Yeah, the cases are each country. Okay, so another thing about this data set, is this data set representing a sample or a population? And having read the book would be helpful.
I believe it's a population because it was giving the decimal, that decimal point represents millions or something, if I remember correctly.
Yeah, so there's two things. So just because they have a population column here with numbers in it doesn't mean the data set is a population. And just because we have a population number doesn't mean we have a population data set. The key in this case is what are the cases? The cases are countries, and in this list, we have 218 countries, which were all the known countries in the world as of last year. So since I'm not missing any country on this planet at the moment, I have every single one. This data set represents a population. The population would be the countries on the planet Earth as of last year. If I only had 10 of them, then it would be a sample. But I have every single country that exists on the planet as of last year. So this data set does represent a population. Then we have all different columns here. So each row is a case. So Argentina is a case, and its case has all these variable values here. Sometimes they're called attributes for those variables. And then we have, rural. Often in a data set, this title isn't descriptive enough. Like, what does rural mean? My guess that's % rural. I'm not really sure. So somewhere there's a description of what each of these variables really means. Like, what does CO2 mean here? Population, 37.172. And I heard someone mention that's probably millions of people. So again, we're missing definitions, and that's always the case in a spreadsheet version of a data set. We have to look them up somewhere else. So notice we have lots and lots of numbers here. And then we have this developed 1, 2, 3, and again, we'd have to look that up. But most of these, my guess is that these are quantitative variables, except for a couple. Developed, where they use the number 1, 2, or 3 to signify some level of development. That number is used as a placeholder for some description. So in this case, I would believe developed is a qualitative variable or a categorical variable, right? Categorical variables split your sample up into different groups. The code is just a shorthand name for the actual name of the country. So these two are clearly names, which makes them categorical. And a categorical variable is any variable that kind of splits the sample or population up into one or more groups. And since names are unique, each country is like a group of itself. All right, let's take a look at another example. Oh, we got more questions. Okay. I got ahead of myself there. Oh, yeah, so this is an important thing. So I'm gonna back up for a second. This is in reference to the syllabus. And in the syllabus, I repeatedly mention spending time on this class. So the general rule for a college class is for each credit hour, you should spend a couple of hours studying on your own. So this is a 4-credit class. So there's 4 hours of class time that like for those of you in the Zoom thing that we work together. And then for each of those 4 hours, there should be 2 more. So that's another 8. So that's 12 hours total. If you split those 12 hours among the 7 days, that's almost 2 hours a day. And so my recommendation is try to find a couple of hours every day. So like we have a couple of hours right here today. That's great. Maybe you spend another hour later. Maybe you take tomorrow off. That's okay. Don't take more than 2 days off, because then you lose the role that you're on in a class like this. So yeah, it does include the time that you spend in these Zoom sessions with me, the 12 hours. And if you're watching this in the future, then that 12 hours counts, watching the video, reading the book, doing the homework. And now that's just like a ballpark estimate. Some people get by with 10 hours and do fine. Other people need like 20 hours. So there were several math classes where it was a 4-credit class, but I spent like 20 hours on that one class each week. And it was just hard for me, and I had to do that. There were other classes where I was like, I get this, just going to class. I don't even need to do any homework. I don't mean to be cocky there, but again, you might have had some classes like that where you didn't have to try too hard and you did okay. You could have tried harder, but you got by. So, it's kind of up to you, your life, what you need to do to succeed. But my recommendation is if you can come to the class or watch the videos, and you can do at least an hour or 2 every day, and you don't miss any assignments, there's no way you can fail this class. So that comment was, with respect to success there. There was another question about, what do you need to do for this class? So you need to read the book. And I don't have too much control over whether you read the book or not, but I try to motivate people to read the book by having homework. The exercises in the book, sometimes I will specifically assign them. Like if you've looked ahead to application 1, which we're not quite ready for unless you read section 2.1 already, I referenced 2 problems in the text here, and I picked even ones in this case because the odd numbered ones, the answers are in the back of the book, which I thought made it a little bit too easy. But you can look at the odd number ones as a guide for how to help answer these even number ones. So here's a case where, yeah, you've got to do those problems out of the book. If I don't specifically reference it, then there's nothing to turn in from the book. And often I will include a link like this, and this is just where the data came from. So when you read problems 2.32, 2.33, 2.34, they're all based on this study right here. And often I have questions about what was posed in the book about this, and I want more information. And so I put this in basically for my own benefit because sometimes I want more detail. So if anyone wants to look up this survey about the American College Health Survey, here's the whole survey in all its gory detail. So do you have to go there? No. Do you have to read the book and check out these problems? Yeah. And then there's the text entry box for your answers here. And as far as your answers go, I'd like them typed up in a Google Doc, and then I want the shareable link to the Google Doc. And I'll re-demo how to do that in just a little bit. Otherwise, you have 3 types of assignments every week. There's the application, which requires you to write something up. And then there are the practice problems, which you get 3 tries on each. And if you get it wrong, it'll show you the answer and you can try again with a slightly different version. And then the reading quiz where you just get 1 try on it. Okay, let's see, I got some more questions in the chat here. All right, so let me look up that question. So which section did that come from? Was that section 1 or 2, Tammy? Section 1, okay. So section 1, 1.15. Give me a sec. Still waiting for my print copy of the book. But I have the ebook in the old edition. 1.15. Okay, that is a big one. Let's bring it over for everyone to see. And blow it up a little bit. Oh, computer tricks for blowing up a screen like this. Control plus zooms in and control minus zooms out. So I'm doing control plus here. All right, let's see. Active learning versus passive learning, which is best? Active classroom learning, students are actively involved. Passive learning indicates they're just taking notes. Recent study measured actual learning under 2 formats as well as their feelings. The study was well designed. Students in a college course are randomly assigned to a class period with either active learning or passive learning. The same content and handouts were used in both. Both instructors were highly rated. After the class, students were asked to rate how much they thought they had learned on a 5-point Likert scale. They also took a 20-question multiple choice exam to test how much they'd actually learned. The results were very interesting. Students thought they had learned more in the passive learning, but they actually learned more in the active learning. Okay, what are the cases? What are the variables? Indicate whether each variable is qualitative or quantitative. Okay, so what are the variables here? We have whether the students were in the active or passive class, so that's 1 variable. Their feelings about it were another variable, and their test scores were the 3rd variable here. Yeah, so I see 3 variables here in question B. And then the variables would be active or passive is categorical. The 5-point scale is also categorical because we're not, because that's just a scale on their feelings. We're grouping them based on that. But the test score is a measurable number, so I would say that one is quantitative. Let's see what they said. Class assignment, so that would be the active or passive, the measure of the feelings. They're claiming it's quantitative. I guess it is a number, but we're using the number to group them. So I think that's debatable there. But the test, the measure, that's definitely quantitative. All right, good question. Let's see, question D. There are 154 students in the passive learning lecture, 142 in the active learning lecture and class. Indicate how many rows and columns the data set would have. And they claimed there were, so they, there could be a column for the student name, but it didn't indicate whether they wrote down the student's name or not. So the 3 columns they're referring to would be just these 3 right here. That's all they recorded on the students. Okay. All right. So so that's it's not a huge deal that, whether we say there's 3 or 4, they're not counting the student's name. They don't indicate they wrote it down. If this were a test question and you wrote 4 and said, I think the student's name is another variable, I would say that's okay. All right, let's see. How would you know that in the future? You pretty much take what is stated here, and they don't state that they use the student's name or student number as a variable. They only indicated that they noted which class they were in, their feelings, and the test score. All right, so got some other stuff to look at here. All right, so I have a chart I made based on the Oregon Health Department's website data. So I have a link to that data here. I'll take you to this page in a second. What this shows is Oregon COVID-19 cases requiring hospitalization. This data was from right before spring break. I grabbed this. And the horizontal scale is percent hospitalized. The vertical scale, excuse me, the horizontal scale is age groups. So 0 to 9 years old, 10 to 19, and so on, 80 and over. There are 2 variables represented here. So what do you think the 2 variables are? And are they quantitative or categorical? So please put something in the chat or feel free to speak to me. I love hearing your voices.
I think the variables are age group and percentage of hospitalization.
Mm-hmm. Okay, so almost. So the age groups appeared because we had a bunch of ages. And then percent hospitalization, that is definitely the other one. Now, what kind of variables are these? Is age categorical or is it quantitative?
Categorical.
Categorical. So we can use, in this case, we are grouping, but the original data would be quantitative because someone's age is a number. So in this case, I would say the ages are quantitative. How about percent hospitalized?
I think that's quantitative.
Okay, so although we have a percentage here, that is a number, right? It came from looking at each patient and saying, were they hospitalized, yes, or were they hospitalized, no? And then based on the yes or no answer, we said, okay, how many yeses were there? Oh, there were 25 yeses out of 100. Okay, so that'd be 25%. So what happened with the percent hospitalization is we took a categorical variable and we presented it graphically as a percentage. which is one of the calculations we can make with a quantitative variable. So I'm just going to make some notes on that here. So this is a summary chart, right? Not the actual data set. And we'll take a look at how to make a summary chart like this in a moment. And the actual data probably looked more like this, among other things. So there was probably a column for the patient, some patient information or identifier. And then we had a column for their age. And then we had a column for were they hospitalized or not. Okay. So maybe I'm one of the patients. I'm 51 years old and I was not hospitalized. My friend Bob, who's 68 years old, he was hospitalized. So then we would count up all the yeses in order to, for a particular age group, identify whether they were hospitalized, and then we present that as a percentage. So thinking to where this percent hospitalized came from, it had to come from a column like this. Either they were in the hospital or they were not in the hospital. And then the age groups had to come from a column that looked like this, where there was just a bunch of ages for those people. Maybe they had date of birth instead, and they had to then calculate the age. That's easily doable in a spreadsheet. So let's have a little spreadsheet fun. And I'm going to put this link in the chat if anybody wants to go there with me to play. And every day in class, I'll try to do some spreadsheet play with you. Okay, so the link is in the chat. Feel free to click it or to watch me for a moment and then try it. Let's see, I had this opened already somewhere. Where did I put it? Over here. Okay, so that should be this website right here. So this is the main page for the Oregon Health Authority. Everything you want to know about COVID in Oregon is on this page here, or linked out to where it is. So right now, the big focus is on vaccines. So I hope that you are someone that is eligible to get a vaccine soon. We're hoping by mid to the end of April that every Oregonian should be able to get at least their first shot. And the data that I was looking at a moment ago, I had scrolled down here to the situation in Oregon. They have these dashboards that have all kinds of data and charts. I'm going to go down a little bit further, and I want to take a look at cases by county and demographic table. So I'm about halfway down the page that I linked in the chat. If you're watching this on YouTube in the future, I'll have that link available in the description of the video. So if I click this cases by county and demographic table, it gives me a whole bunch of things. It gives me the latest numbers in each county. I'm in Umatilla County, so I could scroll down and see what's going on. There have been almost 8,000 cases total since we started counting, and 82 deaths in Umatilla County. I had grabbed this age group data and I just copied and pasted it into a spreadsheet. And often, not always, but often, if there's a table like this in a web page, you can copy and paste it. So I'm just going to do a simpler example than the one I just went over. I'm going to get the demographic data by gender here. And so when I copy a table and I want it in a spreadsheet, I want to be careful to start highlighting right at the beginning of the first thing I need and drag down to just the very edge of the last thing. If you go too far, then when you try to paste it in the spreadsheet might get confused about what to do with it. So again, I want to put this in a spreadsheet so I can play with it. And this is important, right? When we do studies, we collect data. And this, again, this is a summary table. There was a much more extensive spreadsheet with more information that this is just the result of. But it's nice to see pictures of data. So that's what we're going to look at next. So I started right at the beginning, carefully dragged and let go at the end with a touchpad on a laptop. That's kind of a pain, but you get better at it with time. Control C on the keyboard copies. or you could right click or command click or control click, depending on your computer, and copy that. And find yourself a new spreadsheet. So I'm going to go back to my Google Drive here. And pick a place for this. I'm going to make a new sheet. And filing things in folders in Google Drive isn't all that necessary, since you can easily search for things and it'll search titles and content. And then you should be able to, from the first cell, just do a Control V as in Victor to paste. And if you copied it right, it should just drop in there just like it looked. Sometimes I don't want all of these colors and boldness. So another trick is if you do a Control Shift V, so hold Control and Shift and then tap V, that will paste without formatting. And so similar things are from the Edit menu. The first thing I did was paste, which is Control V. And the second thing I did was paste values only, which is Control Shift V, which skips the formatting, like the bold and the color and so on. So there's a couple ways to get that in there. Anybody has a question about copying and pasting data in? So I'm looking at this for a couple of reasons. One, we have a whole bunch of information here, and I just want to think about what this information means. What are the variables involved? So the variables involved here are, let's see, I guess there are 3 variables here that we can see. One is what they're calling sex or gender. Let's take a screenshot of this so I can write on it. So in a summary chart, the variables require just a little bit more thought to identify. So we have sex, aka gender, and this variable has 1, 2, 3, 4 designations: male, female, non-binary, or not available. We didn't have that information when they took it. Other thing that's a variable here is death. Right. Did they live or not? Die. As far as the cases go, everybody in this data set had COVID-19. So I wouldn't say having COVID-19 is a variable for this data set, because everybody in the data set had it. It doesn't vary, right? It's just constant. That's the data set. People in Oregon that had COVID-19. Otherwise, this table has 2 variables to look at: the gender, the sex of an individual, and whether they lived or died. And then we have counts of those. So how many times in the original data set did we found somebody died, right? So this is a summary in this case. And that summary is just a count. How many? Here we have a count of females, right? So that's also summary variable, just a count. And then another way we can summarize is by percent. So this is also just a summary of the original data. We don't actually have the original data set. If we dug around their site, we might be able to find it, but often places don't necessarily publish the original data. You often have to request it. And then they would redact any personal information they didn't want you to have for legal reasons. Okay, so a little bit more fun in a spreadsheet. So I look at this spreadsheet, and the numbers at first glance aren't too meaningful, except I can see there were more males than females. The percent is a little better summary, because I can see, oh, 51% versus 48%. The non-binary rounded to 0, and then 1% was not available there. Often it's nice to have a picture. So I just want to, the main reason I copied that in here, Let's give it a better title. It's often a good idea to title your spreadsheet so you don't have a ton of untitled ones and you wonder, what the heck is that untitled? Why do I have 20 of them? So this, I think I'll call Oregon, COVID, gender. That's good enough title, if I could spell. There we go. And there's a couple things I could do for this data. I might want to make a chart of the available gender designations and how many cases there were. Now, the one at the end of cases, if we look back where I copied this from, that one is a note that explains a little bit about the data, okay? So quick look at that. This includes cases confirmed by diagnostic testing and presumptive cases. What's a presumptive case? Presumptive cases are people without a positive diagnostic test who have COVID-19 symptoms and had close contact with a laboratory confirmed case. Antibody test results are not included in the data. County of residence for cases may change as new information comes in, because it could be a person ended up in a hospital or was tested somewhere that wasn't their original county. So they're referring to the county data up above here. So sometimes it's good to look at those notes to better understand the data that we're looking at. All right, so back here. Usually when we're making a chart of data, we don't put the total in the chart. So I'm just going to highlight the word sex in cases, but I think I'm just going to get rid of that one on cases, and then the numbers up to non-available. And then Google's pretty straightforward. I could either hit the insert chart button or go to the insert chart menu. They both do the same thing. And then Google's going to recommend a chart to me once it thinks about it. Come on, Google. Did I click the wrong spot? There we go. So it picked a column chart, which is also referred to as a bar chart. It looked at the stuff I gave it and it assigned these titles. So the chart title, horizontal title, and the vertical title. Pretty straightforward, not much to change here. We'd probably give it a better title than this one right here. So this, I would say, would be like Oregon COVID cases by gender. And sometimes it's nice to put a little more information, like a subtitle, and I'm going to put the date in there. Let's see, what are we still in? March, barely. Is today the 31st? Yep. If I could add that in there too. Sex, pretty straightforward. Cases, better title there, might be number of cases. More clear. So we want to be clear without being too wordy. That looks pretty good. Now, I often, instead of seeing the actual numbers, I think I'd rather see the percents. Now, the problem with seeing the percents is the cases are in the way. So a cute spreadsheet trick is to, with your mouse, highlight the first group of data and then let go of your mouse. So I let go of the button on my mouse. After the first selection, hold Control and then select the next non-adjacent data that you want. And that allows me to skip stuff in between. So a couple steps, highlight the first group, let go. Hold Control, highlight the second group. And you can keep repeating that if you want and get a bunch of disconnected data. So again, highlight the first group, Control, highlight the second group. And then I can make a chart with the percentages instead. This time it gave me a pie chart. I'm going to switch to the column chart. And the column chart for the percent should look almost identical. Let me zoom out here to the one with the counts. The only difference is the values on the side. These are straight numbers, these are percentages, but they are the same relative height to each other. And the binary is, again, so small we can't see it. So the 18 out of 75,000 isn't even visible here. All right. And so bar chart would be one way to display this data. A pie chart would be another. And for categorical data, we summarize either an account with charts, with a column chart, or a pie chart. Those are pretty much the only relevant options. So here's the pie chart version of it. And again, it needs a better title. So kind of like the title I gave it before, Oregon COVID cases, gender, and putting the date in there is not a bad idea. You could either put it right in the main title or throw in a subtitle. And so we have a pie chart for a summary. All right, so summary of what we were just looking at. So at the moment, I'm focusing on categorical variables. And with categorical variables, right, we have this huge list of numbers, right, thousands of cases. And we're focusing on one or two of the variables. And we generally looking at a big list of numbers or male, female is not very informative. We have to summarize it sometimes. So as far as summarizing categorical variables, we have at first two ways to do it. We could just do a count of each category. I'm going to use variable X for that. So I had X females. What is that? X in this case was 83,640. The other thing we can do is a proportion. Proportions are also often stated as percents, but they could be decimals. Proportion is given the letter P for its variable, and it's calculated by taking whatever the count was, X, divided by N, the sample size. So count over sample size. N always represents the sample size of what we're dealing with here. So in this case, for the female, so P for the females would be equal to that 83,640 for my numerator. That's how many females were counted, divided by the total so far on the sample, which was 164,570. And according to their calculation, that should be approximately 0.51 or 51%. So a proportion could be stated as a fraction, a decimal, or a percent. And so we're going to see that a lot in this course. So that's step one of summarizing a categorical variable. Step two is to then make a summary chart. And so as far as summary charts go, for categorical variables, we could either have a bar or column chart, or we could have a pie chart. Those are the main options there. And we will play more with that later on this morning.